Good morning, student. In lecture 11, class 12, chapter number 3, Electrochemistry. Today we will discuss regarding batteries. Battery is one type of chemical cell, that means electrochemical cell. Electrochemical cell, that means it converts chemical energy which is produced by redox reaction into electrical energy. That means chemical energy is converted to electrical energy in battery. We are using for producing current. That means battery is one type of electrochemical cell. Battery can be classified into two categories, primary and secondary. Primary battery, that means it cannot be charged. That means once the battery is used, then when the reaction is completed in the battery cell, after some time it is becomes dead, that means useless. That type of battery otherwise cell is known as primary, and second one is secondary, that means it can charge, that means chargeable. That means in this case the reaction can be reversed by applying the external voltage. Now example of a primary cell, that means a primary battery, one example is a dry cell. In a daily life we are using, we know as a pencil cell. This is known as Elctrochemistry cell because it was discovered by Elctrochemistry. This is primary cell, that means cannot be charged. Now remember following data, that means anode. That means in a dry cell, a zinc container acts as an anode. Cathode is carbon, that means graphite with MnO2 surrounded with carbon. Electrolyte is paste of ammonium chloride and ZnCl2. Potential of this cell is 1.5 volt. Now usage, this can be used in transistor and clocks and so many small apparatus. Now main thing is what are the reaction by which electricity is generated. The redox reaction is there. In anode always oxidation reaction takes place. In cathode reduction reaction takes place. That means here anode is Zn. That means at the anode Zn is oxidized to Zn plus 2 electron. Now at the cathode reduction reaction takes place. Now cathode is carbon which surrounded by MnO2. Carbon is inert electrode. That means reaction of MnO2 takes place. MnO2 plus. From this electrolyte NH2 plus. Now reduction is addition of electron. Now this is converted to MnO to H and plus. From this ammonia gas is released. That means during this reaction ammonia gas is obtained. This is in gas form. This is react with Zn plus 2. That means when cell is running, then remember this complex is formed Zn NH4 plus 2. Remember. Now, why this is a primary cell? So, because during this reaction, this Mn having oxidation number plus 4, oxygen having minus 2. So, this is reduced to MnOH, OH having minus 1, oxygen having minus 2, that means plus 3. That means during this reaction, manganese is reduced from plus 4 oxidation state to plus 3. Now, this reaction cannot be reversed. That means by applying the external voltage, oxidation of Mn from plus 3 to plus 4 oxidation is not possible. Therefore, this cell cannot be charged. Therefore, it is a primary cell. Now, second example of a primary cell is the mercury cell. That means in a daily life we are using, we can say it is potential. Now in which anode is zinc mercury, that means zinc amalgam. Cathode is paste of mercury oxide and carbon. Electrolyte is paste of OH and geranium. Potential is slightly low, 1.35 volt. Uses low current device like hearing aids, watches, and so on. Now main thing is what are the chemical reactions by which electricity is produced. So anode, and the second one is the cathode. Anode oxidation takes place, cathode reduction. Here zinc to mercury amalgam is there, which is oxidized to ZnO. Now oxidation reaction, that means two electron is there. Now here negative charge is there. How to balance this reaction? So we have electrolyte this KOH. That means OH minus. Now here oxygen is there. Here the hydrogen, here no hydrogen. That means we can write here H2O. That means here 2OH minus. That means negative charge is balanced and hydrogen. Now at the cathode is HCO plus carbon, carbon is not. That means HCO plus 2 electron reduction reaction, which is converted to Hg. Now here negative charge is there. From electrolyte to OH minus. Now right side hydrogen is there to that means H2O. That means the reaction is balanced. Now cell reaction, that means oral reaction, addition is carried on. That means the zinc amalgam plus HgO and ZnO plus Ag. This is in solid form, means solid, this is liquid. That means during the cell reaction, there is no formation of ion. No ion is formed, that means there is no problem of decreasing concentration of ion. That means during this life period, it gives the constant voltage of the 1.35 volt. Again, this reaction cannot be reversed. Therefore, this cell is known as the primary cell. Secondary cell. Example of a secondary cell. Secondary cell, that means it can be charged. First example is a lead storage cell. That means the lead storage matrix is secondary cell. That means it can be charged. In which anode is lead, cathode is a grid of lead packed with lead dioxide PbO2. Electrolyte is 38% of the H2SO4. Solution potential is 2 volt. Uses in automobiles and inverters. In automobiles and inverters, one cell, that means one anode and cathode having voltage 2 volt. So we are using more than one anode and cathode in a series, and you can obtain more voltage. Generally, in automobiles, 6 cells are connected in series, so we can obtain the 12 volt. Suppose we want to obtain the more voltage, then apply the numbers of cells in series. Now, what are the reaction by which this potential is generated? Anode and cathode. Anode is made up of lead, that means Pb. Pb is converted to Pb plus 2 plus 2 electron. Now electrolyte is H2SO4 solution. So this Pb plus 2 combined with SO4 and PbSO4 solid is separated for balancing SO4 minus 2 is here. The reaction is balanced. Now at the cathode PbO2 is there. PbO2 is also converted into PbSO4. Now reduction reaction, that means the addition of electron. Now for balancing purpose here SO4 is there, that means here SO4 minus 2, again minus 4 charge, H plus is added from electrolyte. Now here oxygen is 2 and 4 6, right side is 4, that means addition of. Now when addition is carried out, we are obtaining the overall cell reaction. That means this is the Pb plus PbO2. Now SO4 minus 2, SO4 minus 2 and 4H plus, that means we can write 2H2 SO4 which is converted to 2PbSO4 plus 2H2. The automatic reaction will be balanced. Now this is the cell reaction. This is the secondary cell, that means this reaction can be reversed. That means at anode and cathode. That means when this cell is connected with the external voltage, which having higher voltage than 2 volt, then this can be reversed. That means this is the discharging reaction. Discharging reaction. So when cell is charged, that means what are the reaction in charging? So charging is carried out, then this reaction becomes reverse. That means this anode becomes actually cathode. That means this is the original anode at which reaction takes place. This will be reverse. That means PbSO4 plus 2 electron, Pb plus SO4 minus 2. During charging, it acts as a cathode, remember. And as cathode, it becomes anode. Originally, it is cathode. On which this reaction will be reversed. That means PbSO4 plus 2H2O gives PbO2 plus 2 electron plus SO4 minus 2 plus 4H plus. These are the charging reaction when the cell is charged. And why this is possible? This is a PbSO4, which is a solid form, which is deposited on an electrode, which can be removed. And during this reaction, we can say here H plus and SO4 minus are produced. So we can say during the charging reaction, H2SO4 is generated. Now next cell is nickel cadmium cell, which is also secondary cell. This is a very expensive cell and the production is costly. Anode is made up of cadmium, cathode metal grade containing nickel core oxide, electrolyte is QH, potential is 1.4 volt, and it is used in the calculators. Now at the anode and cathode. Anode, that means CD is converted to CDO plus we can say 2 electron. Otherwise, we can directly write the general reaction, because in a textbook it is not given separately anode and cathode reaction, because anode and cathode reaction are complicated reaction. That means directly, remember CD is converted to CDO. That means we can write directly this reaction during this cell reaction. This is CD. CD is converted to CDO, and this nickel at the cathode. This is converted to there is twice. For balancing, here multiply by 2 and 2 plus H2O. That means here hydrogen 6 is there, and here hydrogen also 6. Oxygen here 5 and 1 6. Here oxygen is 6. So remember this overall cell reaction. There is no need to write separately anode and cathode reaction. Discussion of the fuel cell. In a thermal power plant, electrical energy is produced, but the numbers of steps are more. That means initially burning of the coal, otherwise any fossil fuel take place. From that energy which is produced, that can be used for the conversion of water into steam, and finally steam run turbine, and finally electricity is produced. That means there are the numbers of steps are there. From that, by burning of the fossil fuel, we can convert the combustion energy into electrical energy. That means due to the numbers of steps, waste of energy is more. That means efficiency is very less. Around the 40% efficiency is there in thermal power plant. That means the loss of 60% energy. Now, one new concept is there, which is a fuel cell, in which we can convert the combustion energy of the fuel into directly electrical energy in one step. That means what is the definition? The fuel cell is one type of galvanic cell that are designed to convert the energy of combustion of fuel like hydrogen, methane, methanol, etc. directly into electrical energy. That means the loss of energy becomes minimal. Now here one example is given of hydrogen oxygen fuel cell. The simple diagram is there. Anode is a carbon electrode. This is anode made up of porous carbon. Again cathode is made up of porous carbon. This is cathode. Now electrolyte is a concentrated aqueous anode solution is used. Now we are passing the hydrogen gas on anode and passing the oxygen gas over the cathode. Combustion take place and final product will be the H2O. Now potential of this cell is 1.23 volt, and catalyst finally divided from platinum or palladium is used to increase the rate of reaction on electrode. And this type of cell was used in Apollo program, and by oral reaction of the product water is formed, water vapor. By condensing the water vapor, they use as a water for drinking purpose. Now what are the reaction that are taking place? That means anode and anode we are passing the hydrogen gas. So this hydrogen gas is converted to, this is converted to H2O. Now oxidation reaction are there. That means release of electron is there. Now electrolyte is NaOH. That means OH minus is there. That means for balancing purpose here 2 electron. That means 2 OH minus. The oxygen is 2. That means here multiply by 2. Hydrogen is 4. So automatic hydrogen is 4, 2, and now at the cathode reduction reaction take place. Cathode we are passing the oxygen gas, and that means O2 plus electron, and this is converted to OH minus. And now here hydrogen is there. That means for balancing purpose H2. And now here oxygen is 3. Now balancing, suppose 2 electron and here 2H minus. Then hydrogen is balanced, charge is balanced. Now oxygen is 3 left side, right side is 2. That means here 1 by 2. That means oxygen is also becomes 2. Otherwise multiply by this reaction by 2. And that means here 4 electron. And then here 2H2 and here 4OH minus. This is also balanced reaction. Now to write the overall reaction, here 4 electron 2, but this is also multiplied by 2. That means 2H2, here 4OH minus, 2H2 and 4 electron is there. Again multiply by 2. Now here hydrogen 4 and 4 8, that means here this will be 4. 2H2 is there, that means multiply by 4. And that means addition is there, then 2H2 plus 2 is carried out. 4 electron cancel out, OH minus, here 2H2, here 4H2 is there, that means 2H2. This will be gas form, this is in liquid. That means only product is water vapor is formed during this reaction.